Thanks to the James Webb Space Telescope, JWST, the universe revealed a stunning image in July that was the deepest, sharpest view that humanity has ever taken, spanning from the distant reaches of space to our own Milky Way galaxy. Since its inception, the world has been captivated by this astounding achievement of contemporary engineering, the most sophisticated space observatory ever constructed. The JWST, which was built to explore the far-off cosmos, solve the riddles of star formation, and explore the atmospheres of exoplanets, is revolutionizing our knowledge of the world in ways we never imagined. The JWST observations have recently produced shocking new evidence regarding a possible ninth planet in our solar system, commonly known as Planet 9, which shocked the scientific community and excited the public. Astronomy and astrophysics have been rocked by this discovery, which might fundamentally alter our knowledge of how planets form and the composition of our solar system. For the most recent information on the universe's biggest secrets, please like and subscribe to our channel before we go further into this cosmic mystery. The elusive idea of a ninth planet has been a source of debate among astronomers as well as a scientific endeavor for many years. As anomalies in the orbits of far-off trans-Neptunian objects suggested that a sizable, invisible planet might be hiding beyond Neptune, the idea gained popularity in recent years. Unusual orbital patterns and clustering of these far-off, celestial planets indicated that a large body in the outer regions of our solar system was influencing them. The presence of such a planet is now strongly supported by the JWST's most recent observations, which has rekindled discussions over its nature, origins, and possible implications for our understanding of planetary science in general. The JWST has obtained data that was not possible with earlier telescopes thanks to its advanced infrared instruments. It has gone immense distances and looked through enormous amounts of cosmic dust to reveal the mysteries of our outer solar system. Scientists have been able to map out the suspected location of Planet 9 in unprecedented detail thanks to the telescope's ability to detect small fluctuations in light and faint heat signatures. Their discovery is nothing short of revolutionary. An object that meets the theoretical concepts of Planet 9, a massive planet that orbits far beyond the Kuiper Belt at a distance that may be 400 to 800 times further from the Sun than Earth, and has a mass estimated to be 5 to 10 times that of Earth. It would have been nearly invisible to earlier space telescopes because to the great distance and the extremely cold temperatures. However, we are finally getting a look of this possible ninth planet because of the JWST's sensitive equipment. This kind of revelation has significant ramifications. If verified, it would force astronomers to re-examine and maybe rewrite the formation history of our solar system. This new information would need a re-examination of theories about the migration of massive planets and the distribution of mass. The presence of a planet that far from the Sun may indicate that our solar system has had a turbulent past, with planets being dispersed into unexpected orbits by interactions with other celestial bodies or remains of the protoplanetary disk. According to some scientists, Planet 9 might even be a caught rogue planet, which is an object that originated in another part of the galaxy and was later drawn in by the Sun's gravitational attraction. This poses fascinating queries on the fundamental characteristics of our solar system. The finding may also have a significant impact on our knowledge of the so-called scattered disk region, a region of frozen bodies affected by Neptune's gravity and trans-Neptunian objects, TNOs. If Planet 9 is real, it may have shaped these far-off objects' orbits, offering a believable explanation for their enigmatic alignments and behaviors. Theories that imply comparable processes could be taking place in other planetary systems throughout the galaxy gain support from the discovery that a giant planet may have been influencing the development of our outer solar system. By providing hints as to why certain planets get up in extremely eccentric or far-off orbits while others stay close to their host stars, this discovery may aid astronomers in their understanding of the genesis and development of exoplanetary systems. The finding of Planet 9 has exciting ramifications for the hunt for extraterrestrial life in addition to changing the field of planetary science. There may be moons with life-supporting conditions on a far-off, gigantic planet that circles the Sun similar to Jupiter's Europa and Saturn's Enceladus, which are thought to have subterranean oceans beneath their icy crusts. Tidal heating may warm the innards of Planet 9's moons, even if the planet itself is uninhabitable due to its great distance from the Sun. If there are moons around Planet 9, they might have comparable conditions, which would make them attractive targets for astrobiological research in the future. New horizons and technological breakthroughs are in store. In addition to potentially altering our understanding of the composition of the solar system, the JWST's prospective confirmation of Planet 9 also serves as a testament to the methodological and technological developments that enabled this finding. Technological constraints hindered the quest for a ninth planet for decades. No concrete proof of Planet 9 could be found, despite advancements in ground-based observatories and the expansion of our cosmic view by spacecraft such as the Hubble Space Telescope. By showcasing the ability of next-generation technology to solve long-standing astronomical mysteries, the JWST has revolutionized the field. Its capacity to look into the dark, frigid regions of the solar system has successfully increased the scope of our investigation and made possible discoveries that might have previously escaped humanity. The scientific community now faces both new research opportunities and problems as a result of this revelation. It would be necessary to re-evaluate the dynamic mechanisms at work in our celestial neighborhood if a massive planet were to exist in the outer regions of our solar system. Investigations to learn how such a world might form in such a distant orbit will be prompted by questions regarding the planet's composition, atmospheric conditions, and magnetic fields. Is Planet 9 going to be an ice giant like Uranus, a gas giant like Neptune, or something else? How did it get to where it is now? Future missions and ongoing JWST observations may be able to shed light on these issues, expanding our knowledge of planetary formation and variety. Furthermore, there are important implications for other fields of astrophysics from the possible discovery of Planet 9 by the JWST. The existence and detection of such a planet raises the possibility that comparable things exist in other star systems, which could provide answers for the Planet X phenomena that have been postulated orbiting other stars. Large, far-off planets may be able to explain some exoplanets' unpredictable orbits and possibly provide clues about how planetary systems develop in various scenarios. The prospect of discovering Planet 9-like objects surrounding other stars may rekindle the hunt for exoplanets and areas of space that were previously thought to be too far away or lacking in noteworthy objects. When seen from a cosmic perspective, the idea that a planet might be concealed for so long within our own solar system illustrates the limits of human understanding. The notion that a massive planetary body might yet avoid detection after decades of astronomical monitoring and investigation shows how big and enigmatic our solar system is. It would be a sobering reminder that even our cosmic backyard is full of surprises if the JWST data proves that Planet 9 is real. A new era of research centered on discovering the mysteries of our own solar system, as well as the galaxy's furthest reaches, may be sparked by this revelation. Like the historic discovery of Pluto in 1930 or its demotion from planetary status in 2006, the possible confirmation of Planet 9 might reignite popular interest in space research. A newly discovered ninth planet would probably pique public interest and become a subject of curiosity, conjecture, and awe, opening doors for people of all ages to learn about astronomy and science. Like earlier groundbreaking discoveries, it may inspire a new generation of astronomers, scientists, and space enthusiasts. However, cautious optimism accompanies all the excitement. Even if an object is found to have the expected features of Planet 9, this does not yet mean that it will be recognized as a planet. Thorough data analysis and numerous follow-up observations are necessary on the path from discovery to confirmation. To rule out other possible explanations, such a group of smaller objects imitating the gravitational pull of a single huge item, astronomers must meticulously trace the orbit of the recently discovered object and examine its behavior over time. However, the scientific world is already experiencing a wave of excitement and reassessment due to the discovery's immense potential. The JWST's ability to identify a possible ninth planet in areas where other observatories have failed demonstrates how quickly space technology is developing and raises the possibility that additional long-standing mysteries will soon be solved. One of the most important astronomical discoveries of the century, if confirmed, would be Planet 9, which would drastically change how we view the solar system and our place in it. In addition to validating decades of theoretical research, this discovery would pave the way for future missions that may explore these remote areas and open up new paths for outer solar system exploration. Its scientific consequences are accompanied with philosophical resonance. Philosophical relevance arises from the finding of Planet 9, since the existence of a planet that has never been seen before challenges our conception of the known universe and what our home in space is. It acts as a reminder that enormous discoveries are still awaiting us just beyond the boundaries of our awareness, despite our time of sophisticated technology and space travel. Future generations may be inspired to conduct further in-depth research into the cosmos by this feeling of mystery and the knowledge that our solar system is still incomplete. As we persist in expanding our awareness, we find ourselves on a shared path, a search for comprehension that goes beyond mere finding. The cosmos continues to be a mysterious fabric with strands of interest and awe. We discover more of its complex designs with every new discovery, such as the possible presence of Planet 9, broadening the scope of our collective awareness. The features of Planet May 9 in fact force scientists to re-examine and possibly update their systems for classifying the planets. Our current taxonomy may be oversimplified if this elusive planet displays a special combination of characteristics, such as a dense atmosphere full of unusual gases or indications of geologic activity. A discovery of this kind might cause us to rethink the way we classify planets, possibly even introducing new subcategories or even new classifications of planetary objects that bridge the gap between tiny icy things and gas giants. Furthermore, the speculative characteristics of Planet May 9 cast doubt on established hypotheses about how planets arise in the outermost regions of planetary systems. According to conventional conceptions, gas giants and ice giants usually develop near their stars because there is enough material there to support huge planets before they move away. But if Planet 9 is found to exist at such a great distance, it may indicate that big planets can originate in situ distant from their stars, or that planetary migration processes are much more complex than previously thought. The planetary systems dispersed throughout our galaxy, as well as our solar system, would be significantly impacted by this discovery. In contrast to previous predictions that anticipated their formation would take place considerably farther away, gas giants have been discovered in close orbits around their host stars in a number of exoplanetary systems. Our hypotheses about planetary migration across different kinds of planetary systems could therefore be improved by knowing the origins of Planet 9. Additionally, the Kuiper Belt and the dispersed disk regions, areas that have received less investigation than the inner solar system, may attract renewed attention as a result of the possible discovery of Planet 9. These areas, which are made up of dwarf planets and frozen bodies, orbit the Sun at great distances and might provide more information on the influence of Planet 9 and the history of the outer solar system. The clustering of the orbits of some distant objects, an oddity that first led to the concept of a ninth planet, may be explained by the gravitational pull of Planet 9. A better understanding of the distribution of these populations, and if their orbits have been impacted by a huge undiscovered planet, may be possible through additional mapping of Kuiper Belt objects in the scattered disk using the James Webb Space Telescope. This would demonstrate how enormous worlds influence the structure of the solar system in addition to confirming the presence of Planet 9. Another line of inquiry that is ready for exploration is how Planet 9 might affect cometary dynamics. Long-period comets that occasionally enter the inner solar system are believed to originate from the Oort cloud, a huge and remote comet reservoir that surrounds our solar system. If Planet 9 were to exist, its gravitational pull may have a substantial effect on the orbits of objects in the Oort cloud, either causing more frequent cometary activity or changing the paths of comets that pass close to Earth. Our knowledge of historical epochs characterized by a rise in comet impacts and their effects on Earth's geological and biological past may be enhanced by such discoveries. Scientists may even be able to predict future comet activity patterns by looking at these possible influences, which would provide them important information about the likelihood of impacts on Earth and other planets. Furthermore, the techniques used to find and observe such far-off solar system entities may improve as a result of this discovery. Due to their faintness and the great distances involved, we are currently unable to investigate objects outside of the Kuiper Belt. If there are any other objects in the outer solar system, such as rogue planets or primordial black holes, the methods and tools created for finding Planet 9, such as sophisticated data analysis algorithms and advanced infrared observations, could be used to find them. Our knowledge of the outer parts of the solar system would be significantly expanded if more bodies were discovered using these cutting-edge techniques. exposing a more inhabited and complicated world than was previously thought. The idea that there might be additional sizable, unidentified objects in our solar system casts doubt on the widely held view that we fully comprehend our cosmic environment. The finding of planet May 9th have significant ramifications for the hunt for extraterrestrial life in the field of astrobiology. Because of its severe cold and distance from the Sun, planet May 9th not be a habitable world, but its finding raises interesting concerns about whether massive, distant planets and other star systems could support habitable moons or subterranean ecosystems. In the field of astrobiology, the existence of life on moons like Europa and Enceladus that have subterranean oceans is already widely accepted. If there are moons on Planet 9, they may potentially be potential candidates for underground oceans heated by radioactive decay or tidal forces, similar to those on several of the known frozen moons in our solar system. This finding would undoubtedly increase interest in missions intended to find and investigate underground oceans, expanding the field of astrobiological research to include distant moons with distinct internal heating systems in addition to planets in the conventional habitable zone. Technologically speaking, the difficulty of examining a planet so far from the Sun would test the limits of available space exploration tools. Because Planet 9 is so far away, new methods of spacecraft propulsion would be required because conventional chemical rockets would probably not be able to deliver a probe to such a far-off target in an acceptable amount of time. Such a voyage would require additional development and improvement of alternative propulsion technologies, such as nuclear propulsion, solar sails, or electric propulsion. When these technologies are developed, they may be used for interstellar travel or other long-duration missions in our solar system, creating new avenues for humankind's space exploration. Furthermore, communication is extremely difficult due to Planet 9's immense distance from the Sun. For extended periods of time, a spaceship sent to investigate this far-off planet would have to function independently with sophisticated artificial intelligence to oversee onboard decision-making. It would be nearly hard to communicate in real time with Earth because of the vast distances involved, which might cause delays of several hours for messages to travel across the gap. The development of autonomous systems would thus be accelerated by such a voyage, and its uses might spread to other facets of space exploration, such as mining asteroids and colonizing Mars. By improving the methods used to detect far-off objects indirectly, including by examining gravitational disturbances or minute changes in brightness, the possible discovery of Planet 9 might also change the direction of the exoplanet search. Similar methods could be used to find planets in other star systems that are too faint for direct detection if Planet 9 can be found and investigated using methods that take into account its impact on other objects' orbits. This would be especially helpful in finding exoplanets at the outermost portions of their respective systems, when more traditional techniques like radial velocity or the transit method might not be as useful. Furthermore, new theories about the history of the solar system and its interactions with other stars may be sparked by the discovery of Planet 9. The Sun most likely formed in a stellar cluster, where the orbits of the planets in the early solar system may have been influenced by gravitational interactions with nearby stars. If confirmed, Planet 9's orbit could reveal important information about the early environment of the solar system and whether it has been disturbed by passing stars. By demonstrating how previous star encounters might have impacted the outer planets and changed the distribution of comets and asteroids, this knowledge would expand our understanding of the early years of our solar system. An understanding of these early interactions would provide context for the prevalence or rarity of similar dynamics throughout the galaxy, allowing a view into the larger processes of star and planetary system evolution. Furthermore, the existence of a large planet so far away may suggest that planetary systems become more complicated and chaotic over time than previously thought. Unexpected outcomes like ejected planets, extremely elliptical orbits, or chaotic zones where objects often crash or scatter could result from the gravitational interactions between planets and smaller objects. The hypothesis that additional planetary systems might include similarly chaotic designs, with planets or substellar objects existing in unexpected locations, would be supported if the dynamics of Planet 9's orbit were to indicate a history characterized by large gravitational interactions. Such a discovery would challenge long-held beliefs that have influenced the science for decades and force astronomers to re-evaluate the mechanisms controlling the development and stability of planetary systems. Please subscribe to our channel and give this video a thumbs up if you thought it was interesting. Your opinions would be greatly appreciated. How will this discovery affect science, in your opinion? Comment below. I appreciate you viewing, and I hope to see you again soon.